Alright, hello there. This is Nick Jones recording my video for our fluids project. I'm doing case C, the hybrid combined flow. Let's start with our geometry. There we are. So geometry. These are nice long rectangle. It has a total length of 1.5 meters and a height of 0.01 meters. This fits the aspect ratio of 150 that we were going for. Here is our mesh. Let's see. You have a inlet over here on the left and an outlet over on the right end as our inputs and outputs. We have a top wall, bottom wall. On the left over here, you can kind of see the information about our edge sizing for our mesh. It's got 50 divisions. And here's the face meshing settings that we went for. Let's move on to the setup. Right, now we're getting to the good stuff. You can see here is our inlet going in, outlet going out, top wall. Zoom in here. You can see our fine mesh. Nothing too fancy though. Okay. So let's start with our fluid. We're using air, the density of 1, and a viscosity of 0.0001. These are inlet conditions. I just wanted pressure instead of velocity. I don't know why, but 500 pascals for pressure in. These are outlet, 0 pressure. Also did the option to prevent reverse flow, just so nothing weird happens here. Bottom wall. This is a stationary wall. There's nothing going on here. No slip, that's all. Top wall. So for this type of flow, we have to have a moving top wall. I set the velocity to 0.6 meters per second. I think that's it for our setup here. Yep. Just look. We did for calculations run 500 iterations. I think that covers everything. Right, let's move on to the results. The good stuff. All right. Here we are. This is our velocity profile chart. So as you can see with this chart, we have a nice smooth parabola over here. And if you look closely, you can see there's 2 lines. The red line is the midpoint line, and the blue line is the endpoint line. They pretty much overlap. And that means that our flow is fully developed and reach that state before it hit our exit point all the way up here at the top. I also added a entry flow line here, just so you can see for this type of flow that the initial part of our rectangle doesn't have a fully developed flow. Let's see, where's it right there? Here's our velocity contour. Our maximum velocity for this flow was 23.8545 meters per second. And the max height that it reached was 0.005126 meters. And we ended up with a Reynolds number of 1,590, which is a little high, but it's still lower than our threshold. I think it was like 2,300. So we're good there. I think that covers all of our results here. Shows a fully developed flow. The average velocity for a whole flow is about 16 meters per second, or 15.9 to be exact, which matches our Reynolds number there. Confirms that we have a entirely laminar flow. All right, I think that does it.